Machinists are continually called upon to machine threads. Although there are many different types of thread forms, they are all used for basically two things: allowing a part to be moved along its axis and assembly of parts which can be disassembled later. This videotape will show you a method of roughing a thread with a single point tool and then finishing it with a die. This method may not produce a thread as precise as a machine thread, but it is a fast and productive way to make two parts fit together. After viewing this videotape, you will be able to write down the safety procedures to be observed in the machine shop, list the setup procedures and rough cutting machine threads, and list the procedures for finishing a thread using a die or thread chasing nut. As you enter the machine shop, be sure to put on your safety glasses. Remove all jewelry such as watches and rings, and roll your sleeves above the elbow. This demonstration will show how to machine a 3/4 16 unified national fine thread, 1½ inches long, cut to a line. The length of the thread is usually cut to a line when you are concerned about saving machining time. However, a square groove or undercut at the end of the thread can be used to provide space for threading tool runout. Secure a 3/4 inch diameter piece of stock in a 3-jaw chuck on the lathe with about 3 inches extending from the chuck jaws. Select the proper spindle speed for facing and face the end of the stock. Using the same facing tool, machine a 30-degree chamfer on the faced end of the stock to a depth of the minor diameter of the thread. The minor diameter of the thread can be found by looking at the chart in the machinery's handbook. The minor diameter for a 3/4 16 UNF thread is 673 thousandths. Lay off a line 1½ inches from the end of the stock to mark the length to which the thread will be machined. When the work is properly set up, the next step is grinding the threading tool. The point of the threading tool has a 60-degree included angle, and there must also be front and side clearances to allow the tool to move freely in the groove. First, one side of the threading tool is ground to 30 degrees, or 1/2 of the 60-degree included angle. At the same time, grind 3 to 5 degrees side clearance and an 8-degree front clearance. The tool bit is then turned to the other side and ground to complete the 60-degree included angle with the side and front clearances. Use the center gauge to check the accuracy of the 60-degree included angle. It is important to determine what kind of tool holder will be used in the machining, as this will affect the back rake ground on the threading tool. If the tool is to be held straight in a quick change tool post, no back rake needs to be ground on the tool. If it is to be used in a tool holder, then a back rake must be ground on top of the tool to compensate for the angle of the tool holder. In this demonstration, a left-hand tool holder will be used. Therefore, the top of the tool will be ground 14½ degrees in order to end up with a 0-degree back rake. The next step is setting up the threading tool on the lathe. Place the tool post on the compound and swivel the compound to 29 degrees. Secure the threading tool in the left-hand tool holder and position it so that the cutting point of the tool is at center height of the work. The center gauge is now used as an alignment tool. Place one parallel side of the center gauge against the work so that it is in line with the axis of the work. Then move the tool so that the 60-degree included angle fits in the V notch on the other parallel side. With the tool secured in the proper position, set the machine for cutting 16 threads per inch on the quick change gearbox. Since the carriage will be traveling at a very fast rate in comparison to the feed, it is recommended that inexperienced operators reduce the spindle speed to about 25 to 50 RPM. As a preliminary precaution, Engage the clutch and check that the carriage travel is in the proper direction. Using the crossfeed and the carriage, move the tool to the end of the work and pick up a cut on the work diameter. Set both the crossfeed dial and the compound dial to their 0 readings. Most machines are equipped with a thread-chasing dial and a printed plate telling that when cutting an odd number of threads per inch, such as 9, 13, or 15, the half-nut lever must be engaged at only the numbered graduations on the dial. If you are cutting an even number of threads per inch, such as 8, 10, or 12, the half-nut lever can be engaged at any of the graduations on the dial. In this demonstration, you are cutting an even number of threads per inch, 16. Therefore, the half-nut lever can be engaged on any line of the thread-chasing dial. Set the compound dial for a 5/1000ths initial cut. Engage the half-nut lever when 2 lines on the thread-chasing dial line up to start cutting the threads. Observe closely so that the threading operation can be stopped at the proper time when the cutting tool reaches the line. Disengage the half-nut lever and at the same time back out the crossfeed. This stops the thread on the line. Using the carriage hand wheel, return the tool to the end of the work and set the crossfeed dial back to 0. This now becomes the reference point on the crossfeed for all successive cuts. Stop the machine and check the number of threads cut on the work with the center gauge. If the number of threads is correct, feed the compound in another 5/1000ths and continue to rough the thread, lubricating the work as you go. You need to be constantly aware of the line marking the end of the threads in order to disengage the half-nut lever and back out the crossfeed. If the tool is allowed to run past the line after a depth of thread has been cut, the tool may be broken and have to be reground. Accurately cut threads must be cut to a specific depth. The compound dial may be used to determine a rough thread depth. A general rule for an approximate compound rest travel is 3/4 of the pitch. The pitch of a thread is equal to the reciprocal of the number of threads per inch. In this case, the pitch is 1 divided by 16, or 0.0625. To calculate the compound travel, use the formula 3/4 times the pitch, or 0.75 times 0.0625 equals 0.0468, or rounded off to 47/1000ths. Continue lubricating the threads while making the rough cuts. As the thread depth increases, it may be necessary to reduce the compound feed to about 2 or 3/1000ths for a better finish on the thread. When the compound dial registers a reading of 47/1000ths, the threads will have been rough cut to the proper depth. Most compound dials are direct reading, which means the reading on the dial is equal to the amount of travel of the compound. In cases where the dial is not direct reading, you will have to use twice the calculated travel in order to arrive at the desired compound rest reading. When the thread is roughed, move the threading tool out of the way toward the headstock. The threads may then be finished to size by using an adjustable die or a hexagon rethreading die, also called a thread-chasing nut. The thread-chasing nut speeds up the finishing operation since it has been previously ground for a given size thread. However, it should not be used to remove more than 5 to 10/1000ths of material from a thread. The hexagon rethreading die will be used to finish the 3/4 16 threads to size in this demonstration. Start the die on the end of the thread and apply a generous amount of lubricant on the threads. Use a large adjustable wrench to run the die onto the thread. One way of running the die onto the thread is to set the spindle RPM to a low setting. This prevents the spindle from turning. Now, turn the die by hand. Another and perhaps faster way is to place the spindle in neutral and support the wrench holding the die on the compound. Then, turn the work in the chuck by hand. This same method of holding the die with a wrench and turning the work in the chuck by hand may be used in reverse to remove the die. Some operators may prefer to use power when running the thread chasing nut on or off the work. But power should be used only with great caution and only by an experienced operator. To review this videotape, you have seen the safety procedures to be observed in the machine shop and the steps to follow in roughing and finishing threads on the lathe using a single point tool and a thread chasing nut. These are the steps to follow. The end of the workpiece to be threaded must be faced, and the end chamfered to a 30-degree angle to a depth equal to the minor diameter of the thread. The threading tool must have an accurately ground 60-degree included angle with the proper front and side clearances. The setup of the threading tool is critical for accurate threads and must be aligned with a center gauge. You need to know when to engage the half nut lever when cutting even or odd number of threads per inch, and when to disengage the half nut to prevent damage to the threading tool. When the thread has been roughed to the proper depth, the finishing cuts are made with a rethreading die. This method of roughing a thread with a threading tool and finishing with a rethreading die will produce a part which is interchangeable.